Okay, jumping into homework 3, part A. Our first question is for flow through a pipe described by a pressure drop, lengthen slash diameter of a pipe, and density, viscosity, velocity of the fluid. Write down a dimensional matrix. Demonstrate and explain how determining the null space of this matrix and constrain linear combinations of the null space basis vectors leads to dimensionless groups here, i.e. an automated implementation of the Buckingham Pi method. So how we're going to go at this problem is first setting up our Buckingham Pi method for solving dimensionless numbers. And then we'll jump into what I decided to use with Python, similar in class, and figure out the dot products and all that, and how to determine the null space to eventually get those values. So what I have over here is our six variables that we're working with, which, as I said earlier, is going to be pressure, length, diameter, density, viscosity, and velocity, in that order, because that's just the way they're ordered in the problem. So the first thing we can do is to set up the matrix. So I'm going to do that exactly how I have written and up here on the right, just to make it easier. So let's do that on the top. Make sure everything's recording quick. I always get scared it's not going to record. So there we go. And then on the left here, we're going to have our three units in which these are all measured in. So first we have pressure, which is in pascals. And then pascals are going to be kilogram per second squared meters. So we're going to have, just kind of explain, we're going to need kilograms, meters, and seconds. And as I said, a pascal is a kilogram. So that's going to be in the numerator, so 1. And then second squared meters, so in the denominator. So we're going to have -2, -1. Then our length and our diameter are going to be exactly the same, which is just meters. So we can just put 2 zeros in kilogram and seconds and 1s in our meter spot. And then next we have our row here, which is going to be our density, and density is, I should probably be writing this up. Density is mass over volume, which is going to be equal to kilograms per meters cubed. So in the numerator we have 1 and 0, -3 for meters, and seconds are going to be 0. And I'll also write out pressure. Pressure is equal to pascals, which is equal to kilogram second squared meters. And then I'll just write L and D, both meters. Okay, and then next we have our mu, which is our viscosity. And viscosity is measured as, I think, Pascal seconds, I believe. Yeah, that seems right. So it's going to be the same as our pressure, so kilogram per, and then multiply by seconds. Kilogram seconds per second squared meters. Well, the squared would cancel, this would cancel, so we're going to have kilogram seconds meters. So 1 in the kilograms and -1 for our other two. And then velocity, I probably don't need to write this down, but is equal to meters per second squared. So 0 kilograms meters per second squared. Or, oh my gosh, not second squared. Oops, hold on. meters per second. Jeez. Bad. Okay. Glad I caught that now. Not later. So, now for kind of getting into the harder part right before we jump into Python. Usually we would have what is called the null space over in this general area right here where we would multiply to get to 0. But that is very hard to do by hand and would take a lot of time. So what I'm going to do in this next step is jump into Python and use what we've used in class to get to our dot products and our dimensionless group numbers. So I'm going to switch over my cameras and start screen recording. Okay, so I switched over our cameras and we're in Python now on Colab. I just have a new sheet started here. Up here in my inbox, I just have a screenshot of what we just did on the iPad, so we can look back at that for the array. So what we're just going to do is we're going to start by importing, like always, this numpy as numpy, and import scipy as scipy. Okay, and then what we can do next, let's add a new code. What we're going to do next is do our array. So we're going to have our array is equal to np array. Still recording, okay. np array, and then we're going to have that, and then we're going to need our array, so 1 0 0 1 1 0 1 0, I already forgot. 1 0 0 1 1 0, and then we only need one bracket here, I think. I'll have to look back at that, but these are all going to get messed up. I'll fix the brackets later. Negative 1 1 1, negative 1 1 1, negative 3 negative 1 1, negative 3 negative 1 1, and then we're going to need a bracket. Let's go back. So when I'm hitting enter, that's just telling our command here that we're moving on to the next part of the array. I might have something messed up here with the brackets, but I can fix it later. So negative 2, oh, we need another bracket. Negative 2 0 0, I think it was. Yep. 0 0, negative 1. Oh, this is a negative 1. Okay, so there's some, it might not be messed up. Let me run and see if it's running right. I might have to give it a second. Okay, we do have an error here. We gotta run that first before we run this. So our error list indices must be integers or slices, not tuple. I'll be back after I figure out what's wrong with these brackets and I check syntax. Okay, so I just checked syntax and I'm pretty sure just not having a comma outside this bracket was causing all the issues. Maybe not. Saying 1 is the problem now. Maybe we don't need a bracket there. Definitely need a bracket there. Oh, wait, I see it. It's right here. It's our comma. We're missing a comma. Okay, that seems to be running good now. After multiple syntax errors. Okay, looks good. So let's jump into the next part. Okay, so our next part is just going to be doing some linear algebra to make the null space. So what we need to do is define null space, and we're going to do that by using a linear algebra command built into either numpy or scipy. I'm guessing scipy, and that is sp Lionel g dot null underscore space, which will just do some of the linear algebra for us so we don't have to do that. And let's see if we typed everything good, no syntax errors. So what we should be able to do is just try and get our null space out after we defined it. Okay, cool. And that gives us our first arrays. So everything seems to be running good right now. So what we're going to do now is just be going into more of the dot product stuff and actually find how we find the dimensionless numbers using this system in math. Okay, I'm back after looking up just some other syntax. Still good. Okay. And so what we're going to do after this is we're going to find our C1, which is finding our first dimensionless number finally. And going back to our picture here, kind of how we're doing that is we're going to know that 3 of our numbers here are not going to change, so we can have them static, and we're going to have 3 that are going to change, and the 3 that I decided to choose to stay the same are going to be length, pressure, and viscosity. So those are the 4 that I decided to keep, and then we'll mess with the other 3 to find our dimensionless numbers. And I chose those 3 just because I know those will be the quickest way to get our answer. So defining our C1 here, we have C1 equaling some syntax I had to look up. NP Lionel g dot solve. And then here we can do this, do our null space, and then we can do the 3 that we want, which is going to be 1. So start with 0, we want length, so 1, viscosity 4, and pressure, so 0. So 1, 4, 0. 1, 4, 0. Okay, cool. And then we can move on to no, what am I doing? I need to put a bracket here. Okay, and then we can do our next comes np.array, and we need 2 brackets, and then so we're gonna do 1, 0, 0, and that's going to just, oops, I did not mean to do that. So what this I already said is just for our length, viscosity, and pressure. And so this 1, 0, 0, all we're doing is just solving for this first spot in the array, which will be our C1. And then our second spot, when I'm going to change this to 1 and change 1 to 0, that will be C2, and then same for C3. I'll kind of explain that later once we do those 2. So what I'm going to do is just run this. Oops, we have an error. Okay, there's some kind of error here. I'll find it and come back. Okay, so I found where the error was, and okay, the error was here. We have our comma inside of our brackets, so we need to add that on the outside. And then I already checked, but it does run good. So all we need to do now is just add 2 more blocks of code with C1. That will show us our array, and then we just need to do our null space. and then at, which is what we use for this plugin C1. That will give us our array. So awesome. So what this is just showing is going one by one. We have 1, 2, 3, 4, 5, 6 different values, and we have 6 here. So these are just going in order of what we have. So since I don't have anything to write down, I'm just going to add some text here, and you guys can follow along. So we have pressure, length, diameter. So pressure, length, diameter, and then I'm just going to write out viscosity. I forgot the comma. Viscosity, or I think it's actually density than viscosity. Yeah. Density, viscosity, what's the final one? Velocity. I'm just, actually, no, I'm going to write out vel, otherwise I'm going to get confused. So what this is showing is, for pressure, our value is 1 to the 1e negative 17, which is very close to 0. So we're just going to put that as a 0. And we're going to keep doing this for all the values. So our length, we have 1, so 1. For our diameter, we have -1, so -1. Density is a 0. Viscosity is also going to be a 0, and so is, viscosity is also 0, and so is velocity. So what we're left with here is just going to be length over diameter, because we have our length in our numerator and our length and our diameter are only 2 defined values here, and our length is 1 and our diameter is -1, so they'll go in the numerator and denominator. So we have our length divided by diameter, which is right here, one of the dimensionless groups that we are trying to solve. So also there's one of the values that we're trying to find. So what we can do next is basically just copy everything from C1, like I was explaining earlier, but just change this value here of what we're trying to find. So now we're trying to find the second matrix value, so just change that, and we're gonna define this as C2. Let's rerun these so nothing changes, and then we're gonna just define our C2. Should give us an array of different values, which it does. And then we're going to do our null space our null space at C2. And we get values as we did before with C1. So our pressure is still going to be 0 here. Our length is going to be 0 here instead of 1 now. Our diameter will still be -1. Our density will now change to -1. Our viscosity will go to 1. And velocity will go to -1. So what we're left with here now is 3 numbers in the denominator and 1 in the numerator. So we're going to have our viscosity over our, maybe I shouldn't use brackets. Actually, I will. Over d time, or diameter times density times velocity. So let's see if that's one of our numbers: viscosity, diameter, density, velocity. So yep, okay, so right here we have our Reynolds number that we were trying to find earlier. So we can just put Reynolds number as our C2. So we found our value for C2, and then finally we're just going to do this one more time but with C3. Oops, I didn't mean to do that. So we have our pressure as a positive 1, we have our length as a 0, our diameter as a 0, our density as a -1, our viscosity as a 0, and our velocity as a -2. So what we're going to get in this case is going to be a pressure value over our velocity squared multiplied by density in the denominator. So pressure over velocity squared density. Yep, pressure over velocity squared times our density, which is our final dimensionless group we were solving for here. So hopefully this code helps with trying to find Reynolds numbers, try to help find dimensionless linear combinations of the null space vectors using Python.